Hi, and welcome to this session, which is the deep dive on new container hosting options on Azure App Service and App Service Environment v3 with your host, myself, Stefan Shadkat. So what are we going to go over here in the session today? Well, first off, I'm going to walk through the recently GA'd support for Windows containers when you're running on App Service Environments v3. And then we're going to segue into going over the new options for securing Docker container pulls on the Linux variant of App Service, including things like using managed identities in conjunction with Azure Container Registry, as well as how to use your own private container registry. So let's hop into the content. So let's talk about Windows containers on Azure App Service. We're pleased to announce that with the recent platform update, we now support Windows containers running on App Service Environment v3. Previously, you could only run Windows containers in the public multi-tenant variation of App Service using Premium v3 App Service plans. But now you can go out and run containerized apps with Windows containers in a highly secure and isolated manner using the newest variation of ACE, aka App Service Environment v3. So why might you use a Windows container? Well, a very common use case for that is to enable migration of older ASP.NET applications. And the challenge is sometimes older ASP.NET apps have code paths that will make use of various system calls that are not allowed on the regular version of App Service. And this is a common challenge when, for example, the application is rendering PDF files or rendering HTML files, and as a result, it has to make a variety of underlying graphics calls. Similarly, older ASP.NET applications may require container customizations to support things like installing native DLLs into system directories, installing and registering COM components, things like that. And when you run inside of a Windows container, you can define a Docker file. And inside of that Docker file, you have the freedom to go out and write code that will install all kinds of custom dependencies. Now, how do Windows containers work when they're running on App Service Environment v3? Well, you start out with a container, and the platform will always run those containers using what's called the Hyper-V isolation mode. Now, if you've worked with Windows containers before, you know that there's also a process isolation model for Windows containers. However, on Azure App Service, we always use the Hyper-V isolation model, and the reason why is effectively it's running your container in a miniaturized virtual machine. And that's great because it means that the platform doesn't have to worry about whatever code is running inside of the container, because it's fully isolated off behind that Hyper-V security boundary, and that's why we allow arbitrary code to run inside of the container, and you can go out and customize the dependencies in the container to your heart's content. Now, all of the containers ultimately run inside of an app service plan, and specifically the SKU of that app service plan is the isolated v2 SKU. That's the newer SKU that's associated with ACE v3, and not only does it provide the ability to run Hyper-V isolated Windows containers, it also comes with more powerful CPUs and higher memory options all the way up to 32 gigabytes of memory. Now, you can go out and run as many containerized apps as you want inside of a single App Service Environment v3. You can go out and put all the containers in a single plan. You can deploy them into multiple plans and put them all inside of that secure and isolated ACE v3. Now, an App Service Environment v3 always runs inside of a virtual network, and that means there's sort of two flavors of ACE v3. One of them is called the internal load balancer variation of the app service environment, and this means that all of the apps are running behind a VNet internal private IP address. And as a result, all of the containers would only be reachable over your internal corporate network. The other variation of ACE v3 is called the external load balancer variant, sometimes referred to as the ELB variation. And this just means that all of the apps running in the ACE are running behind an internet-accessible public IP address. And so sometimes that you can use that option because it's a little bit easier to get things set up and it's easier to reach the apps. In fact, you'll see in a little bit when we run through the Windows container demo, we used an ELB variation of the ACE v3 simply for the ease of use because it makes it simpler to get to the apps that are running on the ACE. So a couple of points I did want to call out when you're running Windows containers on App Service. There are a couple of configuration options that you want to keep in mind. The biggie is the memory limits that we have set by default for Windows containers. By default, the platform only allocates 1 gigabyte of memory to each Windows container. However, if you go to the doc link I have referenced here on the slide, there's an app setting you can use to tune the amount of memory that the platform should allocate to each individual Windows container. And so I would expect for a number of mission critical or line of business apps, you probably have a bigger memory footprint than 1 gigabyte. Keep that in mind, because if your app starts behaving strangely or throwing out of memory exceptions, it may be because you're just running with too little an amount of memory, and all you need to do is set the app setting and tell the platform to give more memory to the container. Somewhat related to that, the platform will allow Windows container apps to use all of the available CPU cores on the underlying VM. But sometimes we do get questions from folks that they want to limit the number of CPU cores that can be used by an app, and so there is an app setting that allows you to tune that. And then lastly, sometimes ASP.NET apps will depend upon having stable machine keys, because those machine keys may be used to generate session IDs or other encryption values. By default, when you run in a Windows container, the machine keys will change each time the container restarts. So assuming you don't want that, you will want to use the app settings, again documented at this link below, to define stable machine keys. And that will ensure the fact that the values stay the same across application restarts, across container restarts, and similarly it means that if you scale your app out to 2 or more virtual machines, all of the instances will be running with the same machine key values. So lastly, I just wanted to touch on sort of the logistical item of how do you get the containers up into the cloud. And I wanted to touch on this simply because when you switch to using Windows containers, you no longer can just directly publish a Windows container to Azure App Service. Instead, you have to have a container registry that sits in between you and the App Service platform. Now, you can go out and publish to container registries using things like Azure DevOps pipelines, GitHub Actions, etc. The main thing is just one way or the other, you need to build your app and then put it into a Windows container. And the nice thing is Visual Studio as well as MS Build make that very straightforward. So what I'm showing here is just a few screenshots from inside of Visual Studio where if you right-click Publish on an application that you've set up to enable Docker builds, VS will ask you for information about the Docker Container Registry to use. And when you click into that, you'll see there are a variety of options. You can go out and push your Docker container up into Azure using the built-in Azure Container Registry that's there in Azure all up for everyone. And alternatively, you can go out and push containers to Docker Hub if that's what you use for your registry, or other container registries that are out there. And when you choose Azure Container Registry as a target, you'll see on this screen it will fill in more details that are appropriate to your subscriptions and the choices. And you can see here we've selected one of the Azure Container Registry instances that we already set up for doing the demo here in a little bit. And once you click through this, then what will happen is for a few minutes, depending upon the speed of your internet connection, the Docker container that's already been built locally on your machine will get pushed up into the container registry, and then from there you can now pull it into your application that's running on App Service and go run it. So at this point, what we'll do is I'll switch over to my machine and we'll walk through a small demo showing a containerized app running inside of a Windows container on App Service Environment v3. I'm here in the Azure portal looking at the overview page for an ASP.NET app that's running in a Windows container. And that container is deployed on an App Service Environment v3. Let's take a quick look at just sort of the overall code structure. And I'm looking right now at a GitHub repo that contains this ASP.NET app. Main thing I just want to show is we have a variation of this app that will build the app into a Docker container as a side effect of doing a build either off of MS Build or interactively when you're inside of Visual Studio. And you can see here in the highlighted line that we are creating a Windows container based upon a server core image with ASP.NET and the .NET 4.8 framework in it. And then all the final command is doing here is saying that after Visual Studio or MS Build has completed doing its compilation pass, it will copy all of the artifacts into the container and host it at inetpub www root. So you don't normally have to set anything of any of this info up yourself, because if you go out and enable Docker builds in Visual Studio, VS will automatically generate all of this for you, and you'll be up and running quickly with it. Now, what we did for the app that I'm running through is we then configured the app to deploy its container into Azure Container Registry. So let's take a look here in Deployment Center. We can see, sure enough, that we are pulling from Azure Container Registry, and we're pulling an image called PDF sample. So let's take a look at the Azure Container Registry. I've just popped over here to the repositories drill down for this registry. And you can see, sure enough, we have a repo here called PDF sample. And so when I do a Docker push from a machine or from a build environment like Azure DevOps, this is where the container will actually get pushed into. Now, in the interest of time, we're not actually going to sit here and do a Docker push in real time into the container registry. Probably not surprisingly, if you've worked with Windows containers before based upon a full server core image, you know that in total they're multi-gigabyte images, and so just doing the initial setup and initial push can take a while. But now that we've got the container up inside of the repo, what I want to do is compare and contrast running this app when it's inside of an app service environment versus when it's just running on the regular public multi-tenant variation of the service. So for starters, I'm going to pop over here in the portal to just a variation of the app that's running on Windows App Service. And you can see here it's running on a PV3 instance, so it's not running inside of an app service environment, and for that matter, it's just running as plain old source code. So if we browse to the app, and then if we say, hey, let's go out and try to generate a PDF using some code out there to go out and do a PDF gen with calls to Windows graphics calls, system drawing, things like that, you'll see the traditional yellow screen that tells you something went wrong. And this is sort of proof that the sample app is currently running on the multi-tenant version of the service, because on regular source code running on the multi-tenant service, you have a security sandbox that will prevent your code from making privileged calls like Windows GDI graphics calls. Now instead, I'll pop back over here in the portal to the variation of the app that's been containerized and that is running on the app service environment. And we'll browse to it. We'll see it's the exact same app. And this time around again, we'll say, let's go generate a PDF like from the Surface site, announcing the new Surface. And we'll click the Generate button. And this time around, after a little bit of a pause, we should see a pop-up telling us that it successfully generated the file. So I won't actually drill into it, but this is the output of the PDF of the Surface site on Microsoft.com. And clearly, this call succeeded, whereas previously it didn't. So the reason for that is that when you run inside of a Windows container on App Service, as was noted earlier in the slides, we're running you inside of a Hyper-V container boundary. And that means that for all practical purposes, you're running inside of a miniaturized virtual machine, except it's a container. And as a result, we, the service, don't put any restrictions on you, and you can pretty much make any kind of calls that you want. Now also, like I noted in the slides, we are running this container on an app service environment. And you can see here, what I've highlighted, it's running on what's called the isolated v2 tier. So that's one of the SKUs that tells us that we're running on an app service environment. You can also see right below it, right, it's got a reference to the actual ACE v3 that we're running on. And so if we were to drill into the details for that ACE v3, just to sort of prove to you that, yes, it really is what I say it is, if I come here into the configuration page, we'll see, sure enough, that it is running on an app service environment v3. You can see that right there. Now, like I had noted earlier in the slides, you actually have options when you're running on ACE v3. You can either have all of the apps available on a public internet addressable IP address, which is the case right here, right? So this VIP marked as external, and you can see this is an internet routable address. But also, as I mentioned in the slides, we just did this for convenience, for ease of use, for setting up the demo. You can certainly set up a Windows container, run it on an ACE v3 that uses an ILB, which is the internal load balancer variation of an ACE. And that way your Windows containers can be running on an infrastructure that's completely inside of your corporate virtual network, and that's secured within your firewall and VNet security boundaries. The next topic that we'll go through here is how to do secure container pulls when you're running with containers on the Linux variant of Azure App Service. So the challenge is that your application is integrated with a regional virtual network, and your container is in a container registry like Azure Container Registry, and you want to be able to securely pull that container. And that means both pulling it over the virtual network connection as well as using a less privileged identity than the full registry administrator, as well as avoiding the need to use clear text credentials. Now, there's two parts to pull this off. The first one is setting up both Azure Container Registry and App Service so that the container pulls will flow over the virtual network. This has actually been in the platform for a few months, but we'll go over it in more detail in the demos. But to summarize here, the fundamental steps are that you need to configure your Azure Container Registry with a private endpoint, because that will give your registry a VNet internal address from which you can do the Docker pulls. You configure your application on Linux App Service to connect to the same virtual network. And then you also flip some switches, as it were, in the Linux app to specifically tell the platform to always pull the container over the virtual network. Now, part two is that we've made a relatively recent update to the platform that enables you to set up a managed service identity when you are doing a Docker pull from Azure Container Registry. Now, this is something customers have been asking about for quite a bit. Previously, you could only do the virtual network part of the Docker pull, but like I said, we made a very recent update to the service, and now you can configure your app on App Service with either a system identity or a user-assigned identity, and the platform will use that managed identity when it pulls the container from Azure Container Registry. And the way that works is that you will add the managed identity to a built-in role called the ACR pull role over in Azure Container Registry, and that is a very restricted role that only has rights to do Docker pulls out of ACR. The nice thing is you no longer have to worry about having clear text credentials sitting in your app settings, nor do you need to worry about using things like a full-blown administrator on the registry in order to do the Docker pulls. So let's take a quick look at just sort of how these parts fit together. So we've got the basic building blocks that I think a lot of folks are familiar with. You've got an app running on Linux App Service. It's connected to a virtual network. Similarly, you've got your container inside of the Azure Container Registry. And now the thing is we want to connect all the dots and make that work. So first off, you will have to make use of what's called a private DNS zone in Azure DNS. And the reason for that is that when you set up a private endpoint on your container registry, the private Azure DNS zone is where the DNS name for that endpoint will get registered so that other clients inside of that virtual network can successfully resolve the DNS name to a VNet internal IP address. And again, I've got all this noted, or actually we've already got it written up in docs off to the side, and at the end of the slides we do have a number of links that lead off to, for example, the details of how you set up a private endpoint on ACR, as well as sort of all the steps you take on App Service. So once you've got that private endpoint associated with your Azure Container Registry, you set a configuration setting on your app in App Service that tells us to do the Docker pull over the virtual network. And that means that the container pull will not flow over the public internet. And then additionally, You configure your application with a managed identity, and like I said, it can be a system-generated identity or a user-assigned identity. But once you do that and grant it the permission by way of the ACR pull role on your container registry, then the platform will use that identity when it does the Docker pull from your registry. And so the end result is you now have both the network level security, where the container pull is all occurring over your VNet, and you also have the user credential and authorization level security, where you have a minimally permissioned identity that is doing the pull from the registry. So from here, what we'll do is we'll switch over to my machine and I'll walk you through in a little bit more detail a demo showing all these moving parts coming together to enable secure container pulls when you're running on Linux App Service. I'm here in the Azure portal to walk you through all of the different components that come together to allow us to pull a Docker container securely over a virtual network when you're running on Linux App Service. Now, right now, I am on the screen that shows me all the different components of my resource group. A number of the items are pretty obvious, right? I've got my app service that's running in an app service plan. And because in this case, the app is actually Dockerized, I also pull the container from an instance of the Azure Container Registry. So to start things out, let's just take a look at the application itself, just to confirm that, it's there, it runs, actually does something. In this case, you can see it's using the example Pet Clinic app, so should be pretty familiar to Java folks out there. And just to prove that, yeah, it's running, I'll go click around here and show that, yes, we're able to pull back data and render it. So the app itself is pretty straightforward, pretty meat and potatoes. Main thing is it's running inside of a Docker container. So let's walk through the different pieces that are needed for Linux App Service to be able to pull this container specifically over what's called a private endpoint and Azure Container Registry. And then additionally, you'll also see that we have managed identities set up with the application. So not only will we pull the container from the registry over a VNet, we will also make the pull using an identity as opposed to clear text credentials. So first, let's sort of look at the other fundamental building blocks that all come together to enable this. First off, here we have a private DNS zone, as I'd mentioned earlier in the slides. Typically not something that you would see if you were just sort of running things publicly on app service, but because we need to pull the container over a virtual network, by definition, that means we have to have some place where we can actually store the DNS record that points at the private variation of our container registry. And then probably not terribly familiar to folks, but these two items, the private endpoint and the network interface, these get sort of created together. But it's the private endpoint that gives us a virtual network internal address that can be used for making Docker pulls from the container registry. So let's take a look at sort of how this stuff gets wired up in a little bit more detail. First, I'm going to drill into the DNS zone, and you'll see here it's actually a private zone, and that's an important point here. So up in the corner it says private DNS zone. The reason why is you'll see that it's referencing this private link.azurecr.io. That's really something of a fake DNS zone name, in the sense that if you went to like public Azure DNS, there is not actually a zone that you, me, and everyone else can just arbitrarily look up entries in. But this is sort of the special naming convention you use to create a private DNS zone so that you can host the records that will map from the name of your Azure registry, your Azure Container Registry, to the private IP address. And so you can see here, this is actually the name of our Azure Container Registry, but since we're in our private zone, you'll notice it will resolve to an IP address that clearly is not routable over the public internet. So that's one component of how this works. Second component, of course, is we have to come into the container registry itself and configure a few things. so that it deploys a private endpoint and uses that exclusively for the Docker pulls. So I'm in here in the portal for my registry. If I pop in to the networking tab, you'll notice a few things. Public access has been disabled. So we went out and did this explicitly to drive home the point, like you cannot pull a container from this registry like as you normally would over the public internet or a public endpoint. We've specifically turned that off. Secondly, we have configured the container registry to have a private endpoint. Now, we've done this ahead of time. Underneath the hood, it will create the entries inside of our private Azure DNS zone. And the main thing here is you can see we get a private endpoint that's allocated to it. And that private endpoint can now be resolved by, for example, the web app when it needs to do a Docker pull. And if you take a look here, you'll see here's this DNS entry, the full name of it, right, full ignite, etc., within azure.cr.io. And so this is the actual DNS name that we will end up configuring inside of our web app when we say, hey, where should I actually go to do the Docker pull? So I've got the private DNS zone, I've got the private endpoint set up on the container registry, and I've turned off public access. So at this point, let's switch gears a bit and take a look at what's going on inside of the app itself. So a couple of quick things, just, probably not surprisingly, if we take a look at the networking config, and you'll see here that sure enough for the outbound traffic, it is integrated with a VNet. It's basically the exact same virtual network that's being used for sourcing the private endpoint used by the container registry. The second thing is if we pop in here to our deployment information, initially the main thing to observe is that, yep, we're pulling a container and it's coming from Azure Container Registry. Now, the interesting thing here is like, okay, that's nice, but this isn't actually telling me what is like, where's the registry being connected to, right? What's the actual DNS name? How are we getting there from here, as they say? And so the first thing I wanted to show is just to sort of prove the point that we are not, we're not doing smoke and mirrors and pulling the container over the public internet. Let's take a look at our Docker registry username, which clearly is not a real username. And then for grins, I've scribbled on the Docker registry server password. That's clearly not a real password. And then lastly here, the Docker registry server URL, again, is a completely bogus value. So the reason why I'm doing this is, again, if you've worked with Linux App Service before, you're probably very accustomed to using these three app settings to set things up. And I just wanted to show you here that, again, no smoke and mirrors in the demo. Clearly, I've scribbled on these values. They're completely bogus, and ergo, there's no way in heck that the App Service platform is going to be doing a Docker pull with this info. So how do we connect the dots to actually get things working? So a couple of things. First, we'll take a look at this variable, websites enable, not websites enable app service storage, but the one above it, website pull image over VNet. So this is a new app setting. And it is what tells us that in the platform, when it comes time to do the Docker pull, that we should pull the container over the virtual network as opposed to trying to just pull it randomly over the internet. So that's step one that we need to do here in it. And if we then take a look at the overview blade and we go take a look at the JSON view, and the reason why I'm clicking into this is because it will give us an underneath view of some more config info. Let's take a look at the Linux FX version and take a look at how it's set up. So you can see here that we're telling the platform that we're pulling a Docker container. And then notice here again, look at that URL. That should be familiar now, right? This is the name of our Azure Container Registry, and it's the name of the repo that we're going into. And this also corresponds to the value we saw a few minutes ago, where it's been registered inside of the private Azure DNS zone. So when we resolve this in the platform at runtime, because of the fact that the app setting that we looked at a minute ago says do these pulls over the virtual network, we will resolve this host name using the private DNS zone, and what we'll resolve back is one of those 10.x addresses that's clearly a VNet internal address. So far so good. We've got everything sort of wired up and showing you how things work just to do the Docker pull over the VNet. One extra thing that we also did here, and again, we had mentioned it in the slides earlier, is you can also use a managed identity to do a Docker pull. Now realize I'm showing you this being used at the same time as doing the Docker pull over the virtual network. The reality is, if you want to, you don't need to use a virtual network for your Docker pulls, but you can still lock down your registry and do pulls using a managed identity, which, if nothing else, will get you out of the business of, again, having to use those clear text credentials. Now, in our case here, I'm on the identity screen. You can see we have set up a system managed identity. And if I take a look at the Azure role assignments for this identity, you'll notice once it comes up, sure enough, it's telling me that we have the ACR pull role granted to this identity against this container registry. And that is a standard practice for when you want to restrict access and managed access using RBAC against your container registry. So we're using the built-in ACR pull role, and we've granted that to the managed system identity. Now you'll notice here there's also an option for a user-assigned identity. That's because App Service supports both system and user-assigned identities. For ease, frankly, of just setting up the demo, we went with a system-assigned identity. However, you can absolutely do the exact same thing with a managed user identity. Both of them are fully supported for doing secure Docker pulls. So what we'll do is click over here to the overview, and then we will come into the JSON view. And specifically here, I'm going to look for a couple of settings that control how managed identities are used when we're doing the Docker pull. And you can see here two values are highlighted. The specific one of interest is ACR use managed identity creds. That's set to true. And so when that's set to true, it means we're going to use some kind of an identity. And in this case, we just saw a second ago, it's a system identity. Now, if instead I'd set up a managed user identity, you would have also seen that this second value would get set up with the information needed so that our Docker pull will use the user managed identity when communicating with ACR. But in this case here, we certainly see it set to true, and that's why with this final piece of the puzzle all configured, we will finally be able to do a Docker pull. The network traffic will flow over the virtual network to that private endpoint, and we will authenticate against the registry using the system assigned identity. Now, earlier, of course, I went out and set this all up and ran it, probably all of about an hour ago. So what I'm going to show you is the after effect in the Docker container logs. And we'll drill in here to the logs over here in Deployment Center. And if we scroll back a little bit in time, we'll see a little bit earlier, sure enough, right, I went ahead and made some changes to zero out those Docker registry settings. And of course, when I saved that, it triggered a recycle of the container. And then the net result is we did a Docker run, had to go out and do a pull from the registry. And when we look through it, all of it, the main thing is at the end of it, we successfully have the container up and running and successfully serving requests. Furthermore, I believe probably if I look around a little bit, here, do a quick search just in the log text for MSI. Again, it's not that there's a definitive value that's going to show up all the time, but if you force a recycle of your container and you're actually doing the pull over the VNet and you're also using the managed identity, if I look for MSI, which stands for Managed System Identity, you'll see all over the place, right, some search hits here that are highlighted, which at least gives us an idea that, yeah, sure enough, it does appear we're actually successfully doing the Docker pull using the managed identity. And then, like I mentioned earlier here at the top of the demo video, right, I intentionally zeroed out all of those app settings so that it's impossible for this container pull to actually be succeeding unless it actually really is running over the virtual network connection and being able to successfully resolve, right, this private VNet internal only address that we have registered inside of the private DNS zone. So that gives you sort of a quick walkthrough of all the moving parts and seeing them moving together, right? In summary, You can do a pullover of VNet, and you can further secure it with RBAC using either system or user identities. And then take a look at the end of the slides here for this session, because we do have a link in there that will lead off to an article that will give you, jokingly, all of the gory details, literally line by line, of all of the CLI commands that you can similarly run to set this all up yourself and get up and running with secure Docker pulls on Linux App Service. For the last part of this session, I'm going to walk through what's involved with setting up and using a private Docker registry with Linux App Service. So we're starting out here with, two familiar things. One is a web app that's running on the public multi-tenant version of Linux App Service, and let's assume that it is connected to a regional virtual network. So in order to use a private Docker registry, which is a registry that will provide containers other than, for example, Azure Container Registry or Docker Hub. So it's a do-it-yourself version of a Docker registry. The first thing that you'll probably have is some kind of a custom DNS infrastructure that's associated with your virtual network. The reason why that's an important component is that that custom DNS server will be used by all of the various clients inside of your virtual network, including connected web apps, to do the resolution of the DNS entry for your custom registries. The second piece of the puzzle, of course, is to have an install of your own private Docker registry. So, for example, you might be installing the open source version of Docker registry on your own Linux infrastructure. Alternatively, you might be using a number of different third-party offerings that also provide Docker registries. The main thing is you've got it installed, set up, and the endpoint of your private Docker registry is registered in your custom DNS. Then what happens at runtime is a Linux web app that's configured to do the Docker pull over the virtual network will look at the DNS entry of your custom registry server, will resolve it to the appropriate endpoint, and send the Docker pull command to your private registry, with the end result being that we will successfully pull the container over the virtual network onto the VMs running inside of App Service, and then we'll start it up and you're off to the races. So that in a nutshell is how a private Docker registry is sort of configured to work with Linux App Service. At this point, we'll once again switch back to my machine and we'll walk through a brief demo that shows a lot of these moving parts. So we're in the portal looking at the overview page for the virtual network that we're using for our demo setup of using a custom Docker registry with an app on Linux App Service. And what we're seeing right now is actually a variety of the IP addresses that are in use by the different components inside of our VNet. So real quickly, we'll just take a quick look at the DNS servers, and you'll see that we have configured the VNet to use a custom DNS server. In this case, we only have a single one set up, and you can see it's got the 0.5 address. So if we take a look at these network interfaces real briefly, again, there's the 0.5 address, which corresponds to our DNS server. And then the important thing is this first entry. This is actually the DNS address of our custom Docker registry. So try to remember that it ends in this 0.4. So in a little bit, you'll see as we walk through the demo, we'll want to see an entry come back that proves to us that we actually have our private registry running on this .4 address. So let's pop over in the portal and take a look at our sample app. It's set up on the public multi-tenant version of Linux App Service. You can see here it's just running on PV2, nothing special. It is integrated with a virtual network. The important thing I want to take a quick look at right now is to see how we have configured the Docker pulls for this application. So you'll see here in Deployment Center, it's a container app. And although previously, for example, you saw us using Azure Container Registry, in this case, we're set up to use a private registry. And then we have the DNS entry for that URL and a bunch of other info, including, of course, the image and the tag name. Now, given that server URL, I'm going to pop over to another screen where I am running a handy little web app that a number of folks inside of Microsoft put together. And what it will do is it will allow me to resolve an address basically using a live web app that's running inside of my virtual network. So it's a really handy little way to see whether or not I'm getting the DNS resolution that I expect. And sure enough, you can see there's the DNS entry of my private Docker registry, and as expected, it ends in that 0.4 address, so proof that we are able to properly resolve the endpoint of our private registry. So the last thing is to actually give this app a whirl. So let's go out and browse to it. And initially you just see like, okay, it's a page with a specific color on it. And what I will do is come back to Deployment Center, and I will change the container reference to make it pull a different container. So we have a V1, we'll go switch it to V2 of our container and go save that. And a side effect, of course, of saving this update to the container configuration is that will trigger a repull of the container. And we should be able to see that happening here in sort of near real time. So let's go out and refresh the logs and see what's going on. So sure enough, we can see that, yep, it's telling us it's going to go recycle the container because something changed. And then a little bit farther on, similarly, you can see it recycling again. This is actually the entry of the change we just made. So switching to the V2 version of the container. And you can see, sure enough, it's attempting to pull the container over the virtual network using our private Docker registry. And so it looks like it's actually successfully done it. And if I come back here to my test page and just refresh, you can see, great, the color changed. So again, proof that we clearly picked up a different version of the code. So in a nutshell, that's a quick run through of just showing all of the different moving parts working together in concert. Granted, there's complexity in the sense you, the end customer developer, have to set up the custom DNS infrastructure in your VNet as well as the private Docker registry. But assuming you already have that, and again, from talking to customers, that's not at all an uncommon setup for their corporate environments, you're able to very easily take advantage of that now just by choosing to use a private registry. And then lastly, remember from the previous demo, you do need that app setting to go out and tell us to always pull the image over the VNet, right? So website pull image over the VNet. But once you've done that on the Linux side of the house with the Linux app service, it's really quite straightforward, and it's super easy to go out and make use of your own private Docker registries. So let's wrap up the session here. Over the course of the talk, you learned about the recently GA'd support for Windows containers when you're running on App Service Environment v3, and you also saw the new options for securing Docker container pulls on the Linux variant of App Service, including using managed identities in conjunction with virtual networks, as well as how to use a private container registry with Linux App Service. Now on this slide, I've included a number of links that go into more details. The first one leads to a page that shows all of the various configuration options that we touched on for Windows containers. And the second two links go into all of the details, the steps, the CLI commands, you name it, that are needed to set up the various Docker pull scenarios that we went over in the session. So thank you everyone for taking the time to click in and watch this presentation, and certainly have a good day, afternoon, or evening, wherever you may be.